everyone, myself Nishitha, Assistant Professor, Department of CSIT, working at MLR Institute of Technology. In previous sessions, we have seen about file system structures and file system directories and directory structures and file system tables. So today in this session, we are going to discuss about file system implementation. So let us see the overview of this presentation. In this session, we are going to see about file system implementation. So first of all, what do you mean by a file? A file is nothing but it is a collection of information which is stored in the secondary storage. So here a file is a collection of related information that the file system resides on secondary storage. So it nothing but the file which is stored in the secondary storage and provides some efficient and convenient access to the disk by allowing data which is stored, located and retrieved. So whatever the data which is stored in the disk format, in the file format, the data can be located in some folders. So whenever I want to find such a file, so which place, which file is presented at which folder, maybe in the local disk C drive or D drive or E drive. So or whenever you want to retrieve the data which is deleted or it can be retrieved. So we can retrieve the data by taking from the recycle bin. So why? Because when the data is deleted, it goes to the bin and we can retrieve the data from the bin. That is how we are going to store the data and locate wherever the files are required, and you can retrieve the data whenever you are in the need of that file. Next, file system implementation is an operating system, refers to how the file system manages the storage and retrieval of the data. So whenever you want to store the file system, in the file system, the data which is present, that can be stored, or you can store in the format of in pen drives, you can store the data, or you can use stored in the hard disk drive, or you can use stored in the secondary storage devices also. So on a physical storage device such as hard drive, solid state drive or any flash drive. So the drives may be in the format of hard drive or solid state drive or any flash drive. The file system implementation includes several components. So the implementation of the file contains several components. So what are they? Let us see. So first one is file system structure and second one is file allocation and data retrieval. So how we are going to file system, how we are going to structure it, how we are going to find the files and directories in the stored devices, and file allocation, where you want to allocate the files in a certain storage device or any disk drive or any secondary storage. Data retrieval is nothing but whatever the data which you want to read or write or any update of that file. So let us see, first one is file system structure. In this file system structure refers to how the files and directories are organized and stored on the physical storage device. So whatever the directories and files which you want to store, that are on a physical storage device. This includes the layout of file system data structures such as directory structure, file allocation table and inodes. In previous sessions, we have seen about directory structures and file allocation table and inodes. So directory structures are nothing but single level, two level and tree structure and cyclic and general graph. Whereas a file allocation table based on the start of files and what is the length of that file where you want to map it. Whereas inode, it may be a single and two level and three level. So these are the three different structures we have seen in the previous sessions. In file allocation, the file allocation mechanism determines how files are allocated on the storage device. So whichever or whatever the files you are having requirement, that should be stored in the particular storage device. This can include allocation techniques such as continuous allocation, linked allocation and indexed allocation, or any combination of these techniques. So as in the previous sessions, we have already seen about contiguous allocation, linked allocation and indexed allocation. Contiguous allocation means whatever the length with the sum of the files which is mapped continuously. Linked location means one node is connected with another nodes or another files. That is what linking with the other files. Whereas index location, based on the index value only you can map with the other files. These are the techniques we have seen in the file allocation methods. Whereas next one is data retrieval. The file system implementation determines how the data is read from written to the physical storage device. So whatever the data which you want to read or return the data from physical storage device. This includes strategies such as buffering caches to optimize file input output performance. So cache is nothing but it may be a page cache or buffer cache, or you want whatever the files if you want to optimize it maybe under file input output performance. That is what how you are going to retrieve the data. Next, security and permission for a file system. How you are going to secure the files and what the permissions you are giving the files to the authorized users. See, whenever you want to share the drive link, so you may give the options like viewer, owner or any modification, nothing but editor. So these files giving the permissions to authorized users, only he can or she can add or edit. That is what giving the permissions. Then what do you mean by security? Security means how you are going to secure the files and how you are going to share that files with an password or any authentication key can be transferred to the authorized users. That is what how you are going to secure and give the permissions to the files. So in this file system implementation includes features for managing the files, nothing but giving permission and security. This includes access controls, ACS, access control lists, ACLs, and next one is file permissions and ownership management. So whatever the file permissions you are giving, that should be an unique and you have to give the permission to the authorized users only. Whatever the control can be used by the access control list, and whatever the managing can do with their ownership of the files, whether he or she can edit, modify or any update of that file. That is what giving the file permissions for the authorized users and by producing the ownership for that some file management system. Next, recovery and fault tolerance. The file system implementation includes features for recovering from failures and maintaining the data integrity. So whenever the system failures, the data is lost, how we are going to retrieve or any fault tolerance occurs. So in that case you may share that files to some others. In other systems the data may be stored or the data can be stored in the backend. This includes techniques such as journaling and file system snapshots. So there is a technique such as journaling and file system snapshot for recovery and fault tolerance. Next, how the file systems organized in the layers. They are organized in many layers. What are they? Let us see. First one is input output control level, and second one is basic file system, and third is file organization module, and next is logical file system. These are the layers how we are going to organize each layer with the file system. So input output control. This device drivers acts as an interface between devices and operating system. It is an interface between devices and operating systems. So this is an interface, and they help the transfer the data from disk to main memory. So the data can be transferred from hard disk drive to main memory. It takes the block of number as input and as output. So it may take as input and then output. It gives low level hardware with the specific instructions. So here in this the data can be transferred from one system to other system, and the device drivers can be used the data from disk to main memory, and the block numbers can be used as input or output. Next, basic file system. It issues general commands to the device driver to read and write physical blocks on disk. So it gives the permissions like read and write for the physical blocks on the disk. It manages the memory buffers and caches. It manages the whichever the memory occurs the buffering and cache bufferings. A block in the buffer can hold the contents of disk block, and cache stores frequently in the file system metadata. So the files can be here maybe in the commands, and they give the permissions like read and write for the physical blocks on the disk. They may happens like cache buffering or memory buffering, and they can hold the number of disk blocks, and cache stores frequently used file system metadata for this basic file system. Next, how the file organization module is happening. It has information about files and location of files and their logical and physical blocks. So in this organization, in generally when we want to allocate some files in the disk format or in the folders, so we need specific path to store the files, and we can easily access that files. So maybe a logical or physical blocks. In physical blocks, they do not match with logical numbers of logical blocks number 0 to n. So sometimes the numbers may not match with the physical and with the logical numbers from 0 to n. It also has a free space that tracks unallocated blocks. So it may also tracks the space which is required, and they are tracked from unallocated blocks. So the space will occupy the unallocated blocks. Next, logical file system. It manages metadata information about a file. So it manages some metadata, how the information can be gathered by the file. Includes all the details about a file except the actual contents of the file. In this, whatever the information it may have cannot accept the contents of that file. It accepts the information which includes all the details of the file except the contents which are not required for the file. It also maintains via file control blocks. FCB has information about file and owner. So it may have the information who is organizing this file, and what is the size of that file, and what are the permission given for the authorized users, and where the files are located. So owner, size, permissions, and location of that file contents. So it accepts this ownership of that file, and what is the size, and what are the permissions given to that, and what are the locations for that file contents. This is about logical file system. Next, what are the advantages of this file system? So it has some advantages that is efficient data storage, data security, data recovery, improved performance, and scalability and flexibility. In this, what I mean by efficient data storage, how much data can be stored in the files, whatever the is it efficient to store n number of files at a time. It may be get some buffering, whether the folder is full, how you are going to empty, or how you get the space for new files to allocate it. So let us see how the efficient data storage can be done for the file system. So in this file system implementation ensures efficient data storage on physical storage device. So it requires some efficient usage which is of having some physical storage devices. Whatever the physical storage devices may be, hard disk drive, magnetic tapes, or any USBs or any pen drives. So whatever the data that can be stored in the format in an efficient manner. Next, data security. File system implementation includes feature for managing file security. So for securing the file, the data should be secure, some encryption keys or whatever the permissions can be given from the owner. This ensures that sensitive data can be protected from unauthorized access. Yes, whenever you are giving the proper security to that files, no another unauthorized person can access that file until and unless he knows the secret key of that data, then only he can access, otherwise he cannot access. That is what about data security. How we are going to recover the data? Data recovery. The file system implementation includes feature for recovering from system failures and maintaining data integrity. So when the system fails, we cannot retrieve the data and we cannot maintain its integrity. So this happens when the data recovery may ensure this problem. Improved performance. File system implementation includes techniques such as buffering and caches to optimize file input-output performance. In this technique, such as the buffering and caches may optimize from input output operation performed by this file system. Why? Because when the input and output operation is not performed well, we may get the error. So we cannot access the files. Why? Because the buffering is happening, so we cannot access. So improved performance should be maintained by this proper input output operations to be performed well. And scalability. File system implementation can be designed to be scalable. So it should be designed means scalable. The length or width of the file should be scalable, making it possible to store and retrieve large amounts of data efficiently. So it needs some possible amount to store the data. Why? Because if we want to store n number of files, it may be in GBs. So 10 GB of data to implement or store in that, we need some efficient or scalable data to provide the files in that. So if it is not efficient, the data cannot be stored. So the proper scalability should be maintained to store and retrieve the data for data efficiently. Next, flexibility. Different file system implementation can be designed to meet specific needs and use cases. So flexibility is needed to design the specific needs and use cases for the file system. This allows developers to choose the best file system implementation for their specific requirements. So whatever the requirements, so we are storing 10 GB of data. In that case, if we don't have enough space, so we cannot store the files. Why? Because the flexibility is not in a need. So in that case, we need to have some specific need of data, and we need to use that files in a proper way. That is what about flexibility. Next, what are the disadvantages of this file system implementation? So in these disadvantages are boot control block, volume control block, and directory structure. And per file FCB, mountable, directory structure cache, system wide open file table, per process open file table. So these are the disadvantages. How the boot control block can be happen? It is usually the first block of volume, and it contains information need to boot an operating system. Booting is nothing but whenever the file cannot be need proper information. In that case, the bootings may happen. In Unix, it is called boot block, and in network technology file system, it is called partition boot sector. In Unix, it is called as boot block, and network new technology file system, it is called as partition boot sector. Next, in VCB, volume control block, it has the information about a particular partition. So it has the information about particular partition where the block is free to insert the files, and where the block is empty to store that files. So example, free block count and block size and block pointers. So free block, when it is free, we can insert. Block size, the size is empty, you can insert the files. Block pointers is nothing but addressing the next instruction. So in Unix, it is also called super block, and in NTFS it is called as master file table. In Unix, it is super block, and in NTFS it is stored in the master file table. Next, what do you mean by directory structure? They store file names associated with inode numbers. So in inode, we are having single level, 2 level, and 3 level. In Unix, files names and associated file names in NTFS, it is stored in the master file table. So whatever the data which is happening, that will be stored in the master file table. Next, per file FCB, it contains details about files, and it has a unique identifier number. So it easily has the file control block, and we can easily identify with a unique identifier number. So and so file is having some unique ID, so we can say that that file is related to some XYZ. So we can easily identify with the unique identifier number. And to allow association with the directory entry, in NTFS, it is stored in the master file table. So in new technology file system, it is stored as master file table. Next, what do you mean by mount table? Mount table is nothing but attaching the files. It contains information about each mounted volume. Whatever the attached table to the new files can get the information for each mounted volume. Next, directory structure cache. In this cache, it holds the directory information of recently accessed directories. So whatever the recently accessed directories, that can be easily holds this cache. Why? Because the we can say when we are already I am using XYZ file recently, so it shows XYZ file is recently used by some person. So we can say, or we can easily identify recently used accessing with the some directories. Next, system wide open file table. It contains the file copy of FCB of each open file. So file control block. Whenever the file control block copies from one file to another file, it can be easily opened. Why? Because the copying can be done easily. Per process open file table, it contains information opened by that particular process and it maps with the appropriate system when the file is open, wide open. So here for each process it should be mapping with an appropriate system until and unless the file cannot open. Why? Because the mapping should be done easily, then only the file can be open. Why? Because when the file allocation table is not mapped easily, then the file cannot be opened appropriately. When until and unless the mapping is done easily, then only it can open widely. That is what per process open file table. Next, how the implementation issues are occurring in the file system. So first one is management of disk space and checking for consistency and repairing the errors. And next, locking the files and managing concurrency. And next is performance optimization. In this implementation issue, first one is management of disk space. How we are going to manage the disk space which is available. To prevent space wastage and to guarantee that files can always be stored continuously in blocks. So the blocks which are having the files continuously, each block contains some 10 to 50 files, so that continuous blocks happening for storing the blocks continually. Suppose here A files contains 10 and B files containing 20. So these blocks are happening continuously for the whatever the files can be stored. So it can be happen continuously. The file system must match disk space effectively. So the disk space, whatever the space is needed for the file to store, that should be managed effectively. Free space management and fragmentation prevention and garbage collection are the methods for managing this disk space. So what are the methods for managing this disk space? That is, free space management should be maintained properly and fragmentation prevention should be done and garbage collection. These are the methods how we are going to manage this disk space. And next, checking for consistency and repairing the errors. How we are going to check the errors when the file are not allocated directly. So if an error occurs, so and so file is not found in the directory, what you are going to do? The consistency and error-free operation of files and directories must be guaranteed by the file system. So that should be guaranteed by the file system. Journaling and checksumming and redundancy are the methods for consistency checking and error recovery. So to check the errors, what are the methods we are using here? Journaling, checksumming and redundancy. File systems may need to perform recovery operations if errors happens in order to restore or lost data. So whenever the data is lost or damaged, so in that case we are going to follow some methods or operations to be performed by this file system. What are the checksumming, journaling and redundancy? Why? Because the data is lost, we cannot retrieve or restore the data to whenever it is lost. Why? Because to perform this operation, that is what we are checking, consistency and repairing the errors in the form of journaling, checksumming and redundancy. These are the methods for repairing the errors. Next, how we are locking the files and managing concurrency. To prevent conflicts, guarantee data integrity, file system must control how many process or users can access a file at once. So if n number of users are using the files at a time, so the files of the users cannot access each file at a time. Why? Because n number of users are using the same file at a time. So in that case, it may be a file locking, a semaphore, and other congruency controlling methods are available. So in that case, we are having some methods like file locking, semaphore, and other congruency controlling. So file locking, so locking the files from the unauthorized users. Semaphore is nothing but to solve the critical section problem for the synchronization process. So to solve some problems for which is happening for the files, that may be solved by this semaphore. Next, performance optimization. File system need to optimize performance by reducing file access time. So file access time should be reduced because of the performance to increase or optimize. So increasing throughput and minimizing the system overhead. So while accessing the files, if the throughput increases and then the minimizes the overhead. Here caching, buffering, prefetching and parallel processing are the methods for improving the performance. So to improve the file system performance, we may use caching, buffering, prefetching and parallel processing for the methods of performance optimization. So what are the methods to optimize for this performance to increase the file system is nothing but reducing the file access time, and you are going to increase the throughput, or else to minimize the system overhead. Or other methods are nothing but caching, buffering, prefetching and parallel processing. These are the methods for improving the performance of the file system. So in this session we have seen about file system implementation. So what are the advantages of file system implementation and what are the disadvantages of file system, and what are the issues happen for the file system management. So these are the topics we have discussed in this today's session. Thank you.